So I'm going to do this example using graphical methods, and then I will tell you, I'll go through example or question 3 in the homework and talk about how it's different. But this will be a good review, I think, for addition of vectors. I don't know. I'm debating whether or not I might move your test to Monday then. We'll see how this goes, because this is going a little rougher than perhaps I expected. So here we go. Example 6. For the collision in example 3, we've got momentum initial equals momentum final. Okay. So I've got my momentum of object 1, my momentum of object 2, this is 2, this is 1. So momentum of 1 plus 0, because this object has no momentum, equals my momentum, that's 1 initial, 1 final, plus the momentum of 2 final. Okay? So are we cool with this? So before, what we did is say, okay, well, I broke up my momentum, all my momentum's up into x components and y components, and I added just those together in the x direction to give me this x component. Then I added the y components together to give me this y component. Doing them graphically, I can go straight from this setup directly to my final velocity. Okay? So I'm going to draw this out. These two vectors, I'm going to have this vector going up like a P1 final, looks like this. Okay? We know what this momentum is. Momentum is just mass times velocity. So the mass times the velocity is 6.7. 2 times 6.7 is 13.4, I believe. Is that right? 6.6, yeah. So that's 13.4 kilogram meters per second. I just multiplied the mass and the velocity together. And I'm going to add to that my momentum final for this guy. So this is just 10V, kilogram meters per second. And these two added together, we cool with the addition, the moving the vectors tip to tail. I draw my first. From the tip, I add that guy. We know that they have to equal my initial momentum from this guy here. So this one, we know the momentum for this guy was horizontal. 2 times 8 is 16 kilogram meters per second. We know that the direction of this guy here is 10 degrees south of east. So that's really nice because this guy is perfectly east. So this angle here is 10 degrees. So now I can just use cosine law to figure out this. So I got 10V all squared is going to equal 13.4 squared plus 16 squared minus 2 times 16 times 13.4 cos 10. So 10V is going to equal the square root of this mess. 13.4 squared plus 16 squared minus 2 times 16 times 13.4 cos 10. Oh, dang it, I lost everything. 13.4 squared plus 16 squared minus 2 times 16, 13.4 cos 10. I'm just going to take the, so this, I'm just going to do this. I'm going to square root my answer. I'm going to divide that by 10. Please be the same thing. Oh, look, it is 0.36. So I plugged this into my calculator. I took the square root of it, and I divided it by 10. You want me to see that a little bit more step by step? Okay, here we go.
This is algebra, right?
13.4 squared plus 16 squared minus 2 bracket 13.4 bracket 16 cos 10. Okay, so that's this. Now I'm going to take the square root of it. And then we're going to divide by 10. Because I don't want 10v, I just want v. 0.3643 blah, 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 blah. Kilogram, no, this is velocity, meters per second. Okay? Which if I flip back, you don't, I will, flip back, that's the same velocity we found before. So the graphical works, you just got to make sure you remember where that you're using, you have to use the momentums. You can't just use the velocities. You got to use the momentums because that's what you're adding together. Okay? So this example, we had P1 final plus P2 final equals P1 initial. That's the triangle we set up. For example, for question 3, sorry, are there any questions on this?
How do you close law because you're not trying to find opposite?
I am trying to find an opposite. Yeah, so that's why we use cos law. And then you'd use sine law to find the angle. You'd find that angle there. You know, that's 10 degrees. 180 minus that gives you that little guy there.
How do you know it's exactly
Because this guy's east. This is due east. And this is 10 degrees south of east. We're told in the question. It can't. They have to add together. It can't. Because addition of vectors and conservation of momentum says so. Okay, so if you flip to 3, 3 looks is similar, but it's asking you for something different. So if I zoom in on 3 here, I'm going to do sum of 3 in this space here. It says find the momentum change. Reading the question is really important. The change in momentum. Change in momentum is defined to be P final minus P initial. So we've got an A. Well, do you want me to do A or B? B is a little more gross, so let's do B. You've got initially a 5 kilogram mass moving at 5 meters per second, 30 degrees east of north. So it's doing this. Okay, so that has a momentum of 25 kilogram meters per second, 30 degrees east of north, so this angle here is 30 degrees. Finally, you've got this, 2 meters per second north. So again, it's not velocity we're concerned about, it's momentum. So that 2 meters per second times 5 is 10 kilogram meters per second due north. So that's nice. No, because we're not adding velocities, we're dealing with momentums.
Yeah.
We want change in momentum. Now, if we remember back to how we subtract vectors, okay, this is the same thing as P final plus the negative of P initial. We cool with what I've done here? Okay, so we're going to start with my final vector, and we're going to add to it the negative of P initial. To find the negative of a vector, you just flip the direction, 180 degrees. So that's going to make this vector go like this, and instead of 30 degrees east of north, it's going to be 30 degrees west of south. So this is the negative of that vector there. So then that angle here becomes 30 degrees. That's 10, that's 25. This right here, from the tail of the first to the tip of the second, is going to become your delta P. And then you use cos law to find that, use sine law to find that. 90 minus the whole chunk minus 90 gives you that little chunk right there. So it's going all the way back to addition and subtraction of vectors that we did back in kinematics. The same methods apply. You just got to make sure you're finding what is asked of you. We're not adding the velocity of the wind to the velocity of the plane. We're finding a change in momentum, which is a final minus an initial. So you got to rejig or flip the initial vector and add it to the final vector. Okay. Does this help? Sorry? Yeah, and then you'll find the change in momentum. And then the force vector is force delta t equals delta p. Once you find the change in momentum, divide by the time, it'll give you the force. The direction won't change because time is just a scalar. Change of velocity doesn't matter. Yeah. If you find the change, that's why they get you to find the change in momentum. Because the impulse equation says F delta t equals delta p. I can give you that expression too if you like. It is right here. But we can make it clearer. It is the same thing. But if this helps, give you this equation, by all means, put that on your formula sheet. F delta t equals delta p. Reading the question and understanding what the question is getting you to do is very important. Write out what the question is actually at, like momentum change. Okay, well, what is that? Write it down. It's delta p. Okay, well, which you know, what does delta p mean? Okay, well, that's final minus initial. The more you carry it around in your head and the faster you chug through this stuff, the more prone you are to make mistakes. Or yeah, our speedrunners. The speedrunners need to become completionists. Yeah.